Hello, pre-calculus learners. Today, let's learn about the conic section. Circle. We all know what a circle is, but let's see a simple explanation by describing it. A circle has a perfect round shape, with all points on its boundary distance from its center, thus forming what we all know a perfect circle. Let's take a brief look at its parts. The center is self-explanatory, as it is the point inside our circle, where all points from the circumference are equidistant. Next, the radius is then the distance from the center to the circle's circumference. Thus, the diameter is the distance across the circle to the center, which is basically 2 times the radius.
Now, let's learn about the circle's standard equation. Its standard equation is x minus h squared plus y minus k squared is equals to radius squared, with the highlighted in green representing the location of the circle's center, while marked in red represents the circle's size measured in radius. Now, let's see an example with the given variables. X is equals to 2, y is equals to 4, h is equals to -1, and k is equals to 8. We need to turn these variables into the standard equation. The first step is to find the circle's radius using the distance formula, which is the square root of x minus h squared plus y minus k squared. Let's substitute using the given variables. After substitution, it comes up to square root of 2 minus -1 squared plus 4 minus 8 squared. We can simplify the equation by turning 2 minus -1 squared to 2 plus 1 squared, as two negative signs side by side equate to a positive sign. Further simplify by combining the terms inside the parentheses, which turns into square root of 3 squared plus -4 squared. We then squared both values, which turns into square root of 9 plus 16 squared. By simple addition, we add 9 plus 16 together, making square root of 25. Find the square root of 25. Then comes out our final answer, radius is equals to 5. Therefore, we have come to the conclusion that the circle's center is exactly 5 units away from the circumference.
For step number 2, we are going to use the value of h and k, which are -1 and 8 respectively. Using these values, we can now conclude that this circle center is located at -1, 8. Now that we have found its radius and center, we can now turn to the last step, which is to turn the values into the standard equation. Let's first take the standard equation, which is x minus h squared plus y minus k squared equals r squared. We then substitute the h and k with the circle center, which results in x minus -1 squared plus y minus 8 squared equals 5 squared. Then we simplify to get the final answer. X plus 1 squared plus y minus 8 squared equals 25. We now see that we have turned our initial variables into its standard equation. Using the standard equation, once again, we can see by just inverting the signs, we have found the location of the circle center, hk, and finding the square root of r squared to get the circle's radius.
Now, let's learn about the circle's general form. The circle's general form is x squared plus y squared plus cx plus dy plus e equals 0, and the other has coefficient a on the squared variables. Our main goal is to turn the general form into the standard form using completing the square. Let's go through the steps with an example. This is a bit complicated, so listen closely. Our given for the first example is x squared plus y squared minus 4x equals 32. First, we group the similar variables moving 4x next to x squared, also placing them in parentheses. Then, we find the square of binomial using the coefficient negative 4. First, we divide it by 2, then square it inside the parentheses, equating to 4. We now add 4 on both sides, turning our equation into x squared minus 4x plus 4 plus y squared equals 32 plus 4. It then turned into the standard equation by using the number on the parentheses when we did the square of binomial, making it x minus 2 squared, bringing down y squared, then adding 4 to 32 makes the final answer. We can then find its center and radius by inverting the sign, making the circle center at 2, 0, and finding the square root of 36, which is 6.
For the next example, we have x squared plus y squared plus 10x minus 6y is equals to 15. First, we arrange the similar variables like the first example, but now y squared also has a partner, making two binomials. Next, we find the square of binomial of both and add the results on both sides. We then again use the numbers inside the parentheses on the square of binomial procedure, making our final standard equation x plus 5 squared plus y minus 3 squared equals to 40. Finding the circle center and radius, we again invert the signs of 5 and negative 3, making the circle center at negative 5 and 3, and the radius 7 units from the center, the square root of 49.
And for our third and final example, we have 3x squared plus 3y x squared plus 18x minus 12y equal 9. Before anything else, we need to remove 3 from x squared variables by dividing all values by 3. We then get x squared plus y squared plus 6x minus 4y equal 3. We can now proceed to the standard procedure by first grouping the similar variables, then finding the square of binomial of both x and y. Add the result to both sides and getting the standard equation. Once again by using the values inside the parentheses during the square of binomial, resulting into x plus 3 squared plus y minus 2 squared equals 16. We then find the circle's coordinate at negative 3, positive 2, and finding the square root of 16, resulting in 4. The amount of units separating the circle's center and radius. To conclude, we all need to know the importance of the circle. If you look around, circles are everywhere, from tires, camera lens, coins, plates, glasses, and much more. The circle is truly a shape that makes the words go around.